So this is the 7th problem in the 1.4 online homework, and what we've got to do is we've got to create a composite function where the number of bacteria depends on the temperature, and then we've got this composite function that says the temperature depends on the time. So to build the composite function, every place you see a T in the number of bacteria formula, capital T they're denoting here, we're going to replace it with that 9t plus 1.1. So that's what I did. I rewrote it down here, and every place I saw a T, I left it like this. I just replaced it. In my open math, that's what I typed in to this slot here, and it accepted it. I did not have to expand it out. The person who emailed me for this help did expand it out, and that's perfectly fine. I was just being lazy and didn't want to, and so I wanted to see if it took it. I mean, this was not a nice thing to have to expand or to FOIL out. Now, for part 2 is where the person that emailed me was having a problem. And what you're doing is basically you're looking for when does this equal 133, right? At least for this problem, you might have some different numbers. So, I mean, it's a quadratic equation. We could solve it, set it equal to 0, use a quadratic formula. And that's certainly something we're going to do in next chapter, in chapter 2, chapter 3. But there's nothing wrong with graphing this. I mean, this is the year 2013, and we have that technology. So what I did is I went out to Desmo, and I'll show you in the next slide. So I really fell in love with this Desmo.com website the last couple semesters. It does a nice job. What I did is in this first equation, I type in the equation that I had written, and then I want to see where this equation intersects the line y equals 133. So that's what I did. Is I had it graph the parabola, and then I had it graph that horizontal line, and then I found the intersection. You can just tap on this. You can do this with a graphing calculator also, if you want to. You got to play with the window a little bit, and that certainly works. So this is what I got for an answer. It's at 0.837 hours, and that's what my open math accepted that and said I was right. So that's the process, and I hope that helps you complete this problem.